Hi, I'm Sebastian from the Technical University of Munich and BMW, and I represent you our work on behalf of all co-authors Prior2Former Evidential Modeling of Mass Transformers for Assumption-Free Open-World Panoptic Segmentation, presented at ICCV 2025. Let's dive into it. We will go step by step, starting with our motivation. In panoptic segmentation, individual instances must be separated within semantic classes. As state-of-the-art methods rely on a predefined set of classes, they struggle with novel categories and out-of-distribution data. This is particularly problematic in safety-critical applications, such as autonomous driving, where reliability in unseen scenarios is required. To address this problem, we introduced Prior2Former, the first approach for semantic vision transformers based on evidential learning. Prior2Former extends mass vision transformer architecture by incorporating better priors for computing model uncertainty in pixel-wise binary segmentation masks by their alpha and beta concentration parameters. Contrasting to most other approaches, it does not require prior knowledge like OoD or void supervision or external models. Our proposed Prior2Former consists of 5 key contributions: a better prior hat, predicting the parameters of the conjugate beta distribution for each segmentation mask to accurately describe the model uncertainty. Additionally, we introduce an evidential uncertainty sampling to focus back propagation on the most evidential uncertain pixels. To balance the loss between the alpha and the beta masks, we propose a symmetric dice loss. Both innovations are explicitly tailored towards beta distributions to increase the quality of the associated mask prediction. After the model training, we convert the predicted mask-based evidential scores combined with the expected value of the classes into accurate uncertainty estimates. Finally, we leverage the predicted uncertainties with instance clustering to distinguish between individual unknown instances. In our paper, we comprehensively evaluate Prior2Former across various tasks and settings, primarily focusing on 4 tasks: anomaly segmentation, anomaly instance segmentation, open set semantic, and open set panoptic segmentation. In the first experiments, we evaluate the uncertainty estimation capabilities of Prior2Former for anomaly segmentation, in which we can see that the quality of the uncertainty estimation is very high for our Prior2Former. In a more complex anomaly instance segmentation task, we could show for the OoDIS benchmark that the performance of Prior2Former makes a big step for prior knowledge-free approaches. Also, in open set panoptic segmentation, our Prior2Former shows state-of-the-art performance. In visual examples, we can see the qualities of Prior2Former to identify unknown objects. Also, we can see the high abilities of Prior2Former to distinguish the different instances of unknown objects. Concluding, we introduced Prior2Former, the first evidential mass transformer predicting better prior evidences for assumption-free open-world segmentation tasks. In experiments, Prior2Former achieves in its category state-of-the-art results across multiple open set tasks, and even outperforms approaches which use OoD data, external priors or models, by leveraging a single unified architecture and training scheme. If you are at ICCV, feel free to step by our highlight poster. Thanks.